I've moved on to a job with a pharmaceutical company where I have been asked to find out, there's a new drug used to control fevers, and they want to know the variability of how long it controls the fever for. So not the mean amount of time that it controls the fever for, but really the standard deviation of that time. How much variation is there in how long it controls the fever in an adult? So I've given it to a sample of adults. I've given the drug to a sample of adults who had fevers and measured how long in hours that fever was kept down, how long it effectively curbed the fever. And now I want to find an estimate, a confidence interval estimate of the standard deviation, of how much variation there is. So we are going to find a 95% confidence interval of the standard deviation of the time of effectiveness of this drug. All right, so how are we going to do that? Now, in Minitab, I'm going to be doing my parameter estimation by going to Stat, Basic Statistics, and I have to find the right thing to use. You'll notice there's nothing here about standard deviation. Standard deviation is not an unbiased estimator. It is not something that I can estimate in the same way. However, variance is. And standard deviation is the square root of variance, or variance is standard deviation squared. So if I can estimate things about variance, then I can take square roots to estimate things about standard deviation. So here I'm actually going to be working on variances. Variance is an unbiased estimator. I have only one sample, so I'm going to one variance. All right. Again, much like other parameter estimation that you can do in Minitab, you could have your samples actually in a column, or you could just give it certain sample information, some summarized data. You could give it either the standard deviation or the variance. Right now, I actually have my data in a column itself, so I'm going to say I have one or more samples, each in a column. Perfect. What column is it? It's time of effectiveness, and I'm going to click on my options. I want to work at 95%, great, and again, since I'm doing parameter estimation, I want to leave this as a not equal to in the alternative hypothesis. That'll actually come up when you do hypothesis testing. So I'm going to say OK there, OK here, and what happens is that Minitab now has calculated those confidence intervals for me. So the standard deviation itself was 0.133 hours. That would be my best point estimate. But as far as the time of effectiveness goes, Minitab's actually done it by two methods, the chi-squared method and the bonnet method. Chi-squared is what we're learning in our book. Chi-squared can only be used when you know your data is normally distributed, which is actually, it's telling you right there. The chi-squared method is only for the normal distribution. The bonnet method is for any continuous distribution. So sometimes we use the bonnet method, but we like the chi-squared method when we know something's normally distributed. Let's assume the time of effectiveness is normally distributed. We can use the chi-squared method. Then we're going to say with 95% confidence, the standard deviation of the time of effectiveness is between 0.104 hours and 0.185 hours. And we have done it. We have estimated our standard deviation.